Good morning, everybody. It's really nice to be in the printed electronics community. I used to work with some of you guys, and so now I'm in the business of rigid and bulky and not flexible things anymore. But I hope my talk could inspire you a little bit and give you also an update on what's going on in my world these days. This little humble piece of silicon has changed a lot of things for us the past decades. We started in beginning of last century, so mid last century, with using silicon and chip for mainly industrial applications in PCs, and little by little. The mobile phone eras has revolutionized our life, and now we are in the IoT or information era. I love this graph because you will see a lot of graphs going up in this presentation that shows that through the years, as the complexity goes, we are getting more and more dependent on semiconductor industry. Not only technology, but we also getting more involved. The amount of people are working now these days in this industry also are amazing and growing as well. So by increasing in the demand in chips, in silicons, and in applications around it, we are kind of reaching, let's say, I would call it distributed computing era. Last century, we would, let's say, have a computer, do the calculations, and then we had applications outside or the storage systems far away from that. But these days, we bring in computation closer and closer to the application. And this is resulting in a high demand for data creation, data storage, data transfer, data analysis, and kind of, I think the theme data drives a lot of activities we are doing these days. So this demand for creation of data and transfer of it and storing of it creates a huge demand for data transfer in our infrastructures. And also in parallel, also creates a huge demand for different sort of computation at the let's say, the data centers, but also at the edge. I think that is also quite related to the printed electronics world, where you are trying with rethinking how we use electronics, bring that computation and data creation closer to us, closer to our daily lives. But this results for a lot of challenges for semiconductor industry. So I will touch a little bit how, and from semiconductor industry, we are trying to address these questions. This is the famous Moore's law, which actually is not a law, but it's been treated in the semiconductor industry as a law. It used to be a projection of Gordon Moore, the founder and CEO first founder and CEO of Intel, a projection of how the industry will evolve. And there are different ways we can predict it, interpret it. Some people say this is rather an economic law, so by increasing the amount of transistors in a certain space, we are making it more cheaper, affordable, so that also resulted in the big, huge industry we have now. But the other side of the story is that it also drove for innovation. So this law by itself has resulted in that companies are pushing more and more for better, faster calculations, semiconductor, and so on. And also, and in another way you can look at it is that by increasing number of transistors, which we're talking about billions of transistors in a small area, we have these scaling drivers, I would call. So they scale down and squeeze more and more things in a limited space. And this also drives the need for innovation and enablers that we have to have. So through the years, the Moore's law was basically more about shrink. Two-dimensional shrink, put more stuff in a small surface. But as the time